Right. So I think we are live on YouTube. We'll just coordinate with Vinayak to see if the things are in action. Right. So I think we are live on. Sure. Vinayak, can you also share a quick email to all the participants by sharing the YouTube link? I am sending the link across to you as well. Okay, it's great. I think we have few people join the session online via our YouTube channel.
Okay.
So we'll just start the session in another 5 minutes or 5 to 6 minutes. Yes, Vinayak, I think just push across the the message to all the participants. So in case there is any delay for them to join, in YouTube they can actually go back and rewatch the video as well, right? So that means they could be able to watch the session even though they joined late, okay? Because the previous live stream data will be available. So with that note, I think we should be good to get started from our side. All right. So hello, everyone. Good evening to all of you. Warm welcome to all of you for the 3-day bootcamp on Automotive CAE. So this course will be delivered by Ms. Tara. So she's been the senior FEA engineer at Decibels Lab. And Tara has worked in the industry for over 7+ years and worked for various customers like GM and Altair, and the various areas of meshing and also on the analysis as well. So with that note, it's great to have a trainer like Tara, so who could share her knowledge for the participants out here to know, the way you could get started your career in the CAE industry. Just to set a pre-note to the session, so you would know the automotive CAE industry is a very large, the business sector for various engineering services companies. That means if, let's say, Tata Motors is manufacturing a vehicle, right? So Tata Motors may not perform CAE in-house, right? So they would give the projects to companies which are called Tier 1, Tier 2, or also in cases for engineering services, okay? So in India, we are the largest engineering service providers for automotive CAE. It means even though around the globe, there are many projects, maybe for Jaguar, Land Rover, or it could be BMW or Mercedes or any companies around the world, you name it. A lot of the CAE activities happens in India because we have been considered to be one of the, most available people in the areas of meshing and also for the analysis as well. You take any company, they would have their offshore development center in India, or they will have a company partnered like TCS or Infosys who performs analysis for the OEM requirements in place, right? So they will give the design part, and then the guys at TCS would probably perform meshing. Maybe it's Tata Elxsi or Tata Technologies, or Cientra, various different companies, right? So they all get the project, and then they perform meshing and they perform analysis, or sometimes they only perform meshing, the file is sent back to the OE, and they will perform analysis at the endpoint there. Things can happen like this, right? So that means it's a well-paid job, and also there are a lot of opportunities potentially for engineers in the sector. And with that way, as I said, India has the largest accounts for analysis, and so there is nothing like it for you to learn, analysis toolboxes. So with that note, as I say, there is a great opportunity for everyone to explore your skill sets and build your skill sets to become an FEA engineer, right? So, so how do you get started to become an FEA engineer? So the courses like this can help you. So get started with the Bootcamp, which is a 3-day program. As a part of our 3-day program, we will be covering a lot of interesting hands-on topics. I believe you might have already installed the Altair software in your laptop, because it will be required for you to practice the sessions during the hands-on activities. All right. So with that note, I will hand over the session to Tara. Over to you, Tara, to take ahead the session. And all the best, everyone, and enjoy the session ahead.
Thank you, sir. Hello all. Welcome to the CAE Bootcamp. I welcome all to the CAE Bootcamp. This bootcamp is for 3 days. Here are our contents for the 3 days bootcamp. We are beginning our bootcamp with getting started with the HyperMesh. That is the module 1. In the module 1, we are going to discuss all these parts, starting from downloading the Altair tool, what is the requirement, why we need to do any simulations, and introduction to HyperMesh, what is the HyperMesh contains, and what are the menu bars or any pages which are in the HyperMesh. Those things we are discussing in the module 1. In the module 2, we are going to do the 2D meshing. Like all you are going to do your first 2D meshing using HyperMesh. That we are giving one component, and that is the automotive component. We are starting with that from meshing of that component, that is the 2D meshing. We are going to extract the mid surface, and after the extraction mid surface and all things to be done from the refining topology and deploying the elements using auto mesh option. After meshing and all, we need to clear the quality parameters, that everything should be in the certain range. That thing we are going to clear. All these topics are discussing in the module 2, and we are concluding this bootcamp in the module 3. That we are going to do we are going to create a 3D meshing. That all we are going to generate a 3D meshing for the solid geometry. And in the module 3, we are going to learn what is in solid geometry, how to create solid elements on the geometry, and what are the quality parameters or any checklist which is given to follow the guidelines, and if any additional checks which are required for the 3D meshing. See, all these contents we are going to discuss part by part. As I said, in the module 1, we are going to start with getting started with the HyperMesh. What is an HyperMesh? What is the requirement? Like we have some other softwares also, but why we need only the HyperMesh? And after that, what is the requirement of doing any analysis or any simulations? We'll go one by one. It's good to know if you are already installed in HyperMesh software. If not, you can visit our Decibels website. We have instructed to how to download the HyperMesh software step by step. You can enroll yourself in the Decibel website. We can help you in downloading the HyperMesh software. See, before starting this bootcamp, I just wanted to introduce what are finite element method. Basically, that the HyperMesh, as the name indicates, we are meshing. That the hyper indicates the high degree or a high level of meshing. So what is the meshing? What is the meshing contains? End of all, we are going to create the finite elements. What are finite elements? So those things we'll understand first. As the name indicates, the finite element method. As the name indicates, the finite element method, say any continuous object has infinite degrees of freedom. See, if you are particularly, say for example, you are in one room, or if you are keeping anything in the square box and all, we don't know like how many degrees of freedoms are there. That in our academics, we have learned there are 6 degrees of freedom. 3 translation motion, and the 3 rotational motion. So these 6 degrees will definitely require to define any degrees of freedom for the particular component or particular point or anything like that. But when you are having a component like this, the circle, what you are seeing here, when you are having a component like this, for this one, we are unable to define any degrees of freedom. Why? Because this circle has an infinite points. We can draw a circle using one node, or you can draw a circle using n number of points that the circle contains. So for the component like this, or when the part is like this, it is difficult to analyze it. Here we don't know how many number of nodes are there. We don't know how many points are there. So in this, it is difficult. So what we are doing in finite element analysis is we are taking this circle and we are dividing it. First, what we are going to define, we are dividing it to 3 lines. We are dividing, or else we can divide it to the 4 lines or 8 or 6 or something like that. So the finite element means I am going to divide this one using a finite, means using a known number of lines. Using a known number of lines, I am going to divide it, or I am going to discretize it. See, here I have mentioned the finite element method is reduces the degrees of freedom from infinite to finite with the help of discretization or meshing. It means for this circle, there are infinite number of nodes are there. But when it comes to 3 lines, here I have defined the circle using 3 lines. See, or 3 nodes. So using 3 lines or 3 nodes, I have divided this one. It means I am bringing these circles to the finite number of nodes or finite number of elements using the discretization. It means dividing. How we are dividing? By nodes and elements, I am dividing. Using the nodes and the elements, I am going to divide this circle. It may be a 3 or 4 or even many nodes, we can divide it. It means here, I don't know how many number of points are there. So if I don't know the number of points, I am unable to define the degrees of freedom. Whereas here, I have defined this using 3 lines. I know how many nodes are there. Now, there are 3 nodes in this circle. So I can easily define my degrees of freedom. So here, for these 3 points, I can 6 degrees of freedom or 3 or 2, whatever it is, so that I can have a solution for this one. In our academics, for the finite element analysis, we are studied how to define a degrees of freedom or how to calculate the degrees of freedom and all we have learned. So likewise, we need the number of nodes to define any degrees of freedom from infinite to finite. This is what we are going to do in finite element method. What are elements? See, first we have created with the nodes, then the entity of joining the nodes. Say for example, here the 3 nodes, if I'm keeping the 3 nodes, it doesn't make any sense. I need to connect, I need to connect the nodes. The way how I am connecting the nodes, that become an element. See, all the calculations are made at limited number of points are called nodes. See here, I said 4 nodes. See, here 4 nodes are there. I can randomly keep wherever I want. I can randomly keep these numbers wherever I want. But I need to join these nodes to form some specific shape. I need some specific shape that is called the element. The entity of joining the nodes are called elements. So we know how to define the nodes and we know how to define the elements. So then we can define the finite, we can do the finite element method. This is a theory background behind the finite element method. Basically what we will do, we will reduce the degrees of freedom from infinite to finite using nodes. The entity of joining the nodes are called elements. So specifically, you can take any of the CAE software. We are going to work on nodes and the elements. What you are going to apply, say for example, you are going to calculate some stresses, means either you are going to apply on the elements or you are going to apply on the nodes. Or when you are applying the boundary condition, or when you are going to fix your model, all the activities which we do in HyperMesh, all are based on the nodes and the elements. All our CAE activities in the HyperMesh are under the nodes and the elements. See, in HyperMesh, not in the HyperMesh, you can take any other softwares, especially that the CAE software. Either it may be a triangular shape of elements or the rectangle shape of elements, even the hexagon or octagon elements are available, but we are interested in 3 nodes or 4 nodes elements only. We'll discuss in the HyperMesh one by one. So this is a theory background. What is a finite element method? Next, this is a finite element analysis procedure or an overview of FEA or finite element analysis. See, this is a standard procedure that every CAE industry is following. This is a standard procedure. See that we are starting from the pre-processing or it may be called as modeling. What is a modeling or what is a pre-processing process are? See, there are different pre-processing softwares are there. Example, HyperMesh, ANSA, ANSYS. See, these are the different is the CAE softwares that everything, every activity, the model building, application of material, property details, everything we are going to do in HyperMesh. That the HyperMesh, what is the major what is the major thing that we are every activity for the CAE simulation to run any analysis, that all the major activities, more than the 60 to 70% of work will be done in HyperMesh only. That is starting from importing the CAD. See, in any of the CAE software, we are not building any CAD. It means we are not creating any CAD. We are taking the CAD from the already, we are bringing the CAD from the software which is already built by the design software. Say for example, CATIA, Unigraphics are like that, or Solid Edge. We are importing or we are bringing the CAD to the HyperMesh. After importing the CAD, we do geometry cleanup, we do the required defeaturing or simplification required. There are the different criteria based on the project requirement or the analysis requirement. Based on that, we are going to simplify the geometry according to our requirements. Then after the geometry cleanup and all, we are bringing for meshing. This is our major part of work. The meshing can be done using 1D, 2D or 3D elements. These are the different elements which are available to create which are available to model any kind of geometry. That is 1D, 2D and 3D. After creating all these elements, as I said, there is a quality parameters. That's for example, if you are working in the 1D elements, there are the defined set of parameters based on the project requirement. We are going to keep that parameters, or else in the shortest way I can tell, there is a defined set of range for the values for the elements that we need to keep, like within that range only we need to keep those elements. That is called the quality of the element. That's a quality parameter. After that, we need to assign the material properties as we did in academics, that we are going to do that. If you are going to solve any problem, or if you are going to problem any numerical problem in our subjects, say for example, if you are doing any SOM projects, SOM problems, there we need to apply steel material. There also we are applying. For that, we are going to give the width or thickness of that component. Here in the CAE software, we call it as a property, and the material we need to give. So everything that what we learned in our academics, the same way the materials, that the material contains the Young's modulus or the density or the Poisson's ratio. So everything we need to define for a particular component. Then we need to fix it, no? We need to fix our component, or we need to fix our simulation, that is called the constraints, and we need to give the we need to apply the loads, whether it may be force load, pressure load, or the temperature load. So that thing we need to define. Then the exporting. All these things, all the major activities are done in HyperMesh. That the HyperMesh is in the solver neutral software that which can help to do any kind of simulation. This is a major advantage of using HyperMesh. Then after doing all these activities, we are bringing our component for the analysis. As we know that there are many softwares which to do simulation. Example, OptiStruct, Radius, LS-Dyna for crash. Or if you are looking for any durability analysis and all, you can go with an Astron. Abacus is there. There is the pan crash. There are the different solvers which are available. OptiStruct and the Radius are the major softwares that currently we are using in the CAE industry. And these two softwares are given by the Altair. And after all this, after running some analysis, we need to review the results. Say for example, you have done some components, you have completed some component, you did everything, analysis you done, you extracted the results, everything you have done. But logically, we need to review that whether the defined things are working properly, whether the deformations are correct, whether the applied load is giving a correct results, that we need to check. How to check that? By using post-processing software. So here we are doing pre-processing, and this is a processing, and this is a post-processing. That is, after running any file, it will give us the some results file. So we need to review that results file, that we require hyperview or hypergraph to review the contour plots example, to know where are the stresses, more stresses values are there, to know the displacement values. Or you can use the hypergraph for representation of the graphs. If you want to represent your results using the graph, means you can use the hypergraph. This is an overview of the finite element analysis that every CAE industry is following, starting from the pre-processing to the post-processing. Next, we'll move on to why we need to do all these activities. See, without these activities also, in our past days, without these activities also, we are building the model. There were the automotive manufacturers are there, everything was following. But why we need it? What is the major advantage of using the finite element analysis? This is a major advantage I can tell. See, in earlier days, there were designing the CAD, then there will be a virtual test and build the model, and there is a physical test. Obviously, for the physical test, we need a prototype model. For the prototype model, we need to build any components. So, for example, you are doing some crash test. For the crash test, obviously, you need a prototype that everything should be as per the new car. Say, for example, you are doing some crash test for the car. So everything should be modeled as per the new designed car. So if the test is failing, if the physical test or the prototype test is failing, again you need to go back to the designing the CAD, where it went wrong, why it is not taking the crash load, or why it is not failing within the certain defined time range. So all these things we need to check it again. After checking and all, if it's a fault by the design engineer, obviously it will go for the new design, or redesign it may go. But after the evolution of the CAE software, what we can do is we will build the model in the design software. We'll do the virtual test using the CAE software. That in the CAE software, as I said, take an example of crash test. If you're working in the crash test, for doing any CAE simulation, we doesn't require any prototypes, or we doesn't require any physical model. What we need one design CAD, we need the material data, we need the load conditions and the boundary conditions. We will apply all those things, and we'll run the file, and we will extract the results. In CAE software only, you will get to know what are the stress values or strain values, are all the details you will get to know. But when you are working on the earlier days plans, see, for example, for one component you are working, first time you have used the steel material. For the second time, if you want to use any aluminum component, aluminum or any other material, means again you need to go for the same procedure as I said, building the model using the steel material, then test it. But in CAE, you doesn't require any prototypes. Just by changing the material data properties and all, you can run the file. So you will have the different material set of values, you can have the different load condition values also. You will be having that the software will give every details that the software will give. After taking all the results, you can finalize which are the best results, which is the best material, or which is the under which load conditions your component may survive, or your vehicle may survive, that warranty period. So everything you will get to know using the CAE software. Then after getting all the results, you can push it for the manufacturing. After the manufacturing, you can take for the prototype testing. In the prototype testing, like in the single test, say if you are doing, without using the CAE software also, in the single test we cannot approve for the single test only. In the CAE also same, at least you need 3/4 physical test to finalize the component, to finalize any of the automotive. But whereas like a main advantage of using this CAE is it will save our time, and it will save the manpower, and obviously it will save our money. See, when we are using this CAE software before the manufacturing itself, you can change any of the thickness, you can play with the material, You can go with the, see, first time you are going with the steel, and the second time if you are going for the aluminum, the material change you can do. You can fix your component in a different boundary condition, that also you can do. Or you can change by changing the thickness or width of the component, or changing any design CAD data, or you can try by redesigning the same data. Everything can be done in the CAE software only. By using the CAE software, obviously you are going to save your time, money, and the manpower. These are the main advantage of using the CAE. See, practically if I want to tell, see, you can see this air wing. For manufacturing it will, to manufacture this air wing, it will take so many days. It needs so much of manpower it require. But what if you are not going, if you are not going to model, or if you are not going to analyze this air wing without the CAEs, say for example, to build this it may take 1 month or 2 months or some certain days. But what if you are working on the CAE means, you can define the different material, and you can check the deformation plots before the manufacturing, for which load it can take, or how many displacement, the displacement values and all, you can check it. But without doing the any CAE software, if you are going for directly for the physical test means, obviously that if it is failing for the single test only, again you need to come back and you need to redesign or change the design. Or if the materials are not good, you need to go with that. There are the different, even though if you are using for the same steel material, there are the different grade, there is a different yield of the material, so everything you need to check and you need to do. But using in software, that is a CAE software, that is a simulation software, you can overcome all these problems. See, these are the practical example by that which you can understand what are the main advantages of using the FEA. These are the theoretical aspects you should know before you doing any FEA analysis or any of the FEA simulations. We'll get started to the HyperMesh. See, the HyperMesh window look like this. As we can see, this is the title bar, this is the menu bars, this is the graphical user interface, and there are the different menu pages are available. See, when you open any of the HyperMesh window, it look like this. See, this is the title bar. In the title bar, you can see the version of the HyperMesh you are using. See, I'm using 2021 version. There you can see the title bar. And then below the title bar, you can see there are the different options. There are the file, edit, view, collectors. These are called the menu bars. See, these are the menu bars, and these are also called menu bars only. As we know, in the menu bars, there is a different option available. If you want to create any new file or open the existing file, or if you want to do save or import or export, see, those things are available in the menu bars. This is the menu bar, and this is a toolbar. And where the blue screen, where you are going to see, this is called the graphical user interface. The empty blue screen, what you are looking in the window, this is the GUI of HyperMesh, wherever all your activities are going to implement here only. If you are going for any to change, to create the elements, to view the component, or any activities you want to do, that everything will reflect in this screen only. And these are the peripheral icons. These are the peripheral icons of HyperMesh, and these icons are also available in the functional keys. That's the keyboard shortcut keys. Keyboard shortcut keys are also available for these peripheral icons. And these are the different menu pages. See, there are the different menu pages. As the name indicates, the best way to use the HyperMesh is the name only. It will take us to do what operation it has built. See, in the geometry, you can see all these options. If you want to do any surface, or if you want to edit the surface, or in the 1D, if you want to create any 1D elements, see, these are the different 1D elements which are available in HyperMesh. You can use it for a specific operation. And then in the 2D also, see, in the 2D, if you want to do AutoMesh, or if you want to create any geometries or need to create any mesh, you can make use of all these options. Likewise, the 3D elements also, there are the different 3D elements options are available to generate the 3D elements. And in the analysis page, where if you are creating any simulation file, or if you are going to build or any model or like that means you can make use of all the analysis page option. Like from if you are applying any force load, see, you can go with this force load and you can apply for this. Meanwhile, the tool and the post, if when you are running the file, you are using the post. See, all these pages are available to do the specific operations. See, the surface, what you are going to see, this is the panel. These are called the panel options. These are the menu pages. These are the panel options. See, now if you go for analysis also, these are the panel options. In the surface, if you go inside this surface, means these are the sub panels. See, panels and the sub panels, this is the difference between these two. These are the menu pages. This is GUI, menu bars, toolbars, and this is the peripheral icons, and this is status bar. See, in the status bars, you can see I'm in the geometry page. If I'm switched to 3D page, see, it will show it as a 3D elements. This is status bar. In this status bar, you can see, say for example, you are going to create or you're going to edit some surface. No, see, it will come as a surface edit, trim with nodes. The first option, what you are going to choose, that will reflect it here in the status bar. The activities or the icon which will choose, no, the same thing will reflect in the status bar. These are the different options which are available in the HyperMesh. The main thing is here in the left of this box, it is called model tree. The model tree, the main everything, like if you are going for any componency, this is a model tree. It contains the models, properties, materials, load collectors, system collectors, property details, any load details, control codes, everything which is available in the model tree. As the name indicates, any one model, or you take any single component, all the details of that component, starting from the element to the node ID to the name of the component, everything which is available in the model tree. This is called the model tree. The left side, which you are seeing, this is the model tree. If you click on the anything, something like the components, see, at the bottom also, we can see some of the options. See, I'm going with this first component. See, it will show the bracket name. This is the name of the bracket. This is the ID of that. This is called the entity editor. These are the model tree. The model tree means the every details or the anything what it contains, this particular file, everything will reflect here only. All the things which are reflect here only. But if you want to edit something, means you can take this to the entity editor and you can do the activities. These are the main icons which are available in the HyperMesh to do any of the operations or to do any of the certain defined, like if you are interested to create the 2D elements, go for AutoMesh. Here the AutoMesh option is there. You can do it and you can do it or you can create it. But the same option, see, this AutoMesh option is available in the 2D page. And as I said, it is also available in the functional key also it is available. In the HyperMesh, there are the 24 shortcut keys are there, starting from the F1 to F12 plus Shift F1 to Shift F12. There are the main functional keys that the like all these operations what we are seeing in the quick edit panel. This is also available in the shortcut key. To do meshing or to create or to project anything, those are available in these pages also, or in these panels also it is available, and it is also available in the function shortcut keys also it is available. We'll move on to the next slide. See, we have learned this is the model tree. As the model tree, as I said, it contains the solver information, it contains the material information, and this is the entity editor. So all these are available in HyperMesh. And what is the geometry, or what are the different kinds of geometry that we can import it in HyperMesh? See, as I said, the HyperMesh is a solver neutral software. As we can import a few, the major software, that the major design software that we can import. Importing means I'm just bringing one CAD which is already built in the design software. Say here one option is there, the green option, as you can see here, the green arrow is there. The arrow indicates it's I'm bringing to the HyperMesh. The red arrow is there, that is to the outward side it is showing, it means I'm exporting. Say importing, if you go means there are the different options you can import. You can import the assembly, you can import only the solver deck. That means you can import only elements also you can import, or else you can import the CAD geometry. As I said, in the CAD geometry here, see, you can import the IGS file, you can import the SolidWorks file, you can import the STEP file, CATIA file, Unigraphics file. There are the different that the HyperMesh supports to import the CAD file. You can import it, or you can open the file. See, you can open the file. If you go for more, open the model, see, you can open the different files which is built by the HyperMesh, or else you can import the other files which is built by some other software. See, there is a difference between opening the file and importing the file. So in opening the file means I'm just opening the file which is built in the HyperMesh software. Importing means that is done by the some other software and I'm bringing to my HyperMesh. So those things, those options are available in HyperMesh. And the same way we can export it. See, we can export the model. You can export the assembly level also, you can export the elements also. And if you want to export only the only the CAD files means that is also available. You can export these two files. These are the best way to use the HyperMesh. And we'll do some small activities in HyperMesh. See, we'll do some small activities like setting from the user profile, how to rotate it, what are the model tree contains. So component view, property view, we'll do some activities in HyperMesh. See, as you can see, this is an empty window. I'm just opening one CAD. See, this is how the CAD looks. As you can see in my screen, this is one of the simple bracket. This is one of the simple bracket. I'm going to show, see, this is a simple bracket. I'm going to keep in a mixed view. Why? Because to represent the geometry lines. See, what are geometry lines? As you can see here, you can see the two kinds of lines. The red lines, see here the red lines you can see, and this is in green lines. What it indicates? As the red line indicates, it is a free edge. This is a free line of the component. It means inside you can see it's in hollow or empty. It means it is a free edge, whereas the green line indicates this is shaded between the two surfaces. See, this is a geometry, how to differentiate the geometry means if it is the green means it is a shade between the two, and if it is a red means if it's a single surface. See, this is how the element looks. These are the elements what you can see in my screen. These are the elements which is built in the HyperMesh. See, as I said, these are called the nodes. See, these are called the nodes. See, the yellow ones is the nodes, and this is the four. See, this is the four-noded element, and this is a three-noded element. See, as I said, this is a tri-element, and this is a triangle. Sorry, square element or a rectangular element. See, if you come over here, it contains the load collector. See, it contains the load collector, it contains the load steps, it is having a material. See, if you switch on that material and if you click on that material, no, see all the details are available. This is Young's modulus, this is the Poisson's ratio, this is the density of the material. So every details are available in this one. So see how to, first of all, we should know how to rotate or how to zoom the component. See, I'm using the control button. In the control button, I'm using the mouse right button also. See, to move within the panel area. See, I'm using the control plus mouse right button. And if your control plus left button means you can rotate it. See, you can rotate it. You can rotate it. And if you want to zoom in and zoom out, just press on the key on the control button along with the mouse middle button. See, if you scroll the mouse middle button, you can zoom in and zoom out. See, we know how to import the file and how to rotate the component and how to zoom in and zoom out. Or if you want to do any, see, you can play around with this GUI of HyperMesh. And we have learned what are the things which are available in HyperMesh, any component, what it may contains. This is the element view. See, this is the geometry view. See, this is the geometry view. So all these which are available in HyperMesh. See, next we'll move on to the topology. What is in topology and why it is required and all, we'll discuss in HyperMesh only. I'll open the new file. See, if you open any CAD, first we need to review the CAD thoroughly before taking it for topology correction. What is in topology means, as I said, we are not creating any CAD in HyperMesh. We are taking the CAD from the some other design software. After taking that CAD, we need to review the CAD before the meshing. See what are all the checks to be done. See, I'm keeping it in a mixed view for the geometry representation. See, if you are keeping in a mixed view, you can see what are the free edges or what are the shared edges. Those things we can differentiate. See, in the topology correction, what we need to do, what we need to learn is, see, here, surface is missing. Here you can see some surface is missing. But I feel it is a missing CAD. Here surface is not there. It is having some valid reason that this feature is going to end here. But if the surface is not here means it is a missing CAD. This comes under topology corrections. Basically, the topology correction means we are going to correct the geometry, or we are going to modify the geometry, or we are going to create any washers or simplification of the geometry that comes under in the topology corrections. We'll do some small activities using the topology correction. See, as the name indicates, topology means changing the shape or changing the size. Here I'm not doing anything. I'm just modifying the geometry. See here, here the CAD is missing. So I need to create some surface. Before generating the meshing also, some corrections or simplification or modification that every component required. Every component it has to correct before taking it for meshing. Why? Because after creating if you are not clearing the geometry, also you can generate the elements, you can finish the component. But what matters is the way the geometry is, likewise only we will get the elements. If the geometry is good, obviously we will get a good kind of good quality of elements. If the quality of the elements are good, the results will be as per our requirement. See, the results of the analysis is directly proportional to the quality of the elements. It all depends on the how quality or how good the elements are. Like that only that you will get the corresponding results. How we will get the good quality of elements? Obviously, our geometry should be very good. How to get a good geometry? How to get a good geometry means by doing the topology correction, by modifying the geometry, or by doing the required changes to the geometry. We will get a good elements. Then the good quality of elements. Then we can get, obviously we will get the good analysis results also will get. So one to other, it is interlinked between one to other. So here we need to create a CAD, and the gray ones are called points. The yellow ones are the nodes, and the gray ones are called the points. See, there are the free points are there. This needs to be removed. And here some circles are there, and we need to create some circles. And here also some missing surfaces are there. So we need to create the missing surface. See, the basic operation is the basic topology correction is a quick edit, or which is also available in Shift F9. In the F9 it is available. See, in the F9 also it is available. In F2, if you go for F11, you can see the quick edit panel option. See, starting from the split to surface, I'll show you. See, if I want to cut this line, see, I just go on selecting one node and I'll just do it like this. So from here to here, if you want, you can do it. See, if you want to cut any lines, you can cut the lines like this. See, if you want to cut like this, you can do it. This is as per the node, it will work. But if you switch on to the lines, select a node. See, I'm choosing this as a node and I'm giving the destiny here. See, perpendicularly, it will split. But if you're selecting and randomly, if you want, means you can use this one. So these are the basic things we should know. Then we'll move on to creating the surface. How to create the surface? See, you can go by surfacing. You can select the nodes in which axis you want, or in the global axis also you can create, or by creating the local axis also you can create. I go by creating the surface using the 2D. Using the 2D option, I'll go to the panel called ruled. If you click on the panel ruled, there is a sub panel will open. Here I'll choose as a line, and here also I'll choose as a line. Here I'm keeping, I want only the surface, I'm switching this to surface. Then choose the lines. Choose the lines. Choose the line list and create the surface. See, surface is created. So like this, you need to think, okay, where are the surfaces are missing? You need to create the surface like this. Or if the surfaces are not missing, or if the really that is a missing CAD, go by creating the surface. Or else if the surfaces are like this is a valid reason that here some circles are coming. If the circles are coming means it might be in a bolt hole, that the bolts may come or nuts may come, any screws may come. Say for example, in our academics we have studied that M10 bolts, M12 bolts. To represent the bolts, these circles are there or these holes are there. This might be in normal hole and this might be a bolt hole. But there are the different procedures for the bolt holes. That what is that means, I'll tell you. See, this is how we need to create the surface. I'll finish off this one. See, like this, you need to choose the lines and you need to create the surface. See, we have created the surface. We'll move to the circle side. Say, for example, it is a bolt hole. So, how to represent a bolt hole? For the bolt hole, we are going to create one washer. Why it is required means obviously there are the most stresses all the time. There isn't stress in the bolt. So, we are going to create one washer. So, choose some washer diameter and create the washers like this. Wherever the bolt, this is an elliptical hole. This is a normal hole, sorry, normal circle. This is an elliptical circle. So, where and all you want, you can create the washers. So this comes under topology corrections. We have learned that how to create the nodes or how to split the line. We have learned how to create the missing surfaces too. And we know how to create the washer also. Then the other important thing is how to remove the points. The same in the quick edit panel. And in the quick edit panel, you just observe, you have an eye on these gray points. So you just deselect this one. See, these are not required for my meshing. I'm just removing. See, I can remove this gray one, but I cannot remove this one. Why? Because this is a free gray. See, you can see this is a free point. I can remove it, but this one I can't remove it. Why? Because it is connected. It is connected by the line. It is not free. So these are the major topology correction which we need to do. And one more is the toggle option. See, if you click on the toggle option, as the name indicate, toggling means I'm suppressing that line. See, here we have just created this line. No, I'm just toggling this line. You just observe, if I click on the toggle line, as you can see some of the dotted lines, it means I'm suppressing the edge or else I'm masking that one, which is not required for me. Why it is not required? See, as you can see here, if you come for these fillets, there are too many lines are there. These too many lines I'm not at all required for my meshing. So what I do, I'll just go and toggle the lines. See, like this, so that I can have a single continuous surface. In this single continuous surface, I can create my mesh or I can create my elements also. And one more thing, here the toggle means we are suppressing. Like once it's suppressed, no, you can see some dotted lines. Again, you can retain this line just by going the right click on the same toggle panel. You just do the right button option. Left button is for toggling the line and the right button is for untoggle the line. So this is the main difference between toggle and untoggle the lines. Next comes to the unsplit line is there. See, unsplit line means, see, these are the lines just I have created. These lines, you can toggle these lines and you can unsplit the line. See, you can observe it here. Here the dotted line is there. I'm in the unsplit option. You just click on this. It is not retaining any points. Why? Because these are the lines which I have created. This is not an original CAD line. For the original CAD line, you cannot unsplit. See, you cannot unsplit. For the original CAD, you need to do toggle. For CAD like this, the lines which we have created, that can be unsplit, or else you can toggle the lines. And you can do the Control Z for the undo option. See, here the undo option is there. You can retain all your activities back. See, these are the these many times we have did the corrections. and you can retain back all these activities. So these are the main topology correction which we need to do before we are taking for before the component goes for the meshing. Why we are doing means, one example I show here. See, I'm just for the example purpose I'm showing. I'm selecting the surface and I'm meshing. See here, there are no distractions here. We got somehow the elements are generated. We can see the elements flow and all. But here, see, there are some abnormal lines or abrupt lines are there on the surface. If you choose this, no, see how the elements flow. See how the flow of elements are there. So for this is the reason we need to clear the geometry. By clearing the geometry, we will get a good quality of elements. If the quality of the elements are good, definitely we will get a good results. So for this reason, we need to clear the topology option. The topology option is available in the quick edit, and F11 also it is available. We know how to split the line, how to create the washers, toggling and all. Delete surface is also there. See, if you click on that one, you just go and select the surface, automatically it will get deleted. See, it will get deleted. You just click on this one. The quick edit panel is the main panel which we use for topology corrections. See, you just go on delete option, but the same delete option is also available in functional key F2. If you click on the functional key F2, see, you can delete all these types. You can delete the elements, you can delete the components or whatever you want, groups, assemblies, or points, tables, what are the activities or what you can create in the HyperMesh. All the things you can delete it. See, there are the 2 pages are there. You can delete the things whichever you don't want. Select the surface, say delete. See, the surface is deleted. If you want it back, you can do the Control Z. Okay, like this. And one more is the functional key F1 is for changing the color. See, you can change the color of the component. If you go for F1, if you go for Shift F1 means you can change the color of the component. See, select the component. You can choose whatever the color you want. You can set the color. You can change the color of the component. So like this, you can change it. Or else here only you can come to the model tree. Here, choose this one. You can change this one. And what you are seeing is component. No, the component means it contains the CAD and it contains the elements also. This is called the component. See, you can create the component here also. Say create, and you can whatever you want to create, assemblies or output blocks, materials, everything you can create it. Or you can create the collector here too in the menu bar. In the menu bar also you can create the collectors. Here also you can create the collectors. There are three ways to generate any collector. See, I just go by clicking on the collector. It is the name called part. If you want to change the name, you can change. See, I'm changing it to bracket. You can change the name. You can change the name. If you want to change the ID, you can change. I'm making to 100. You can change anything number you want. That will reflect it here. Or else you can go by selecting this one, select the component, and you can change whatever you want. So these are the ways you can change the component. The component means just I'm collecting the surface and I'm just keeping the elements and nodes and surfaces to the single component. That is called the collectors. See here the name as component. Inside the component you will having a different collectors. It is collecting the data. It might be in lines, surface, nodes, or elements, or things like that. It will just collect the informations. And we have discussed and we have enough discussed on the topology correction which is required before the meshing. And I hope that everything what I discussed is useful for you guys. We'll move on to the next slide. See, this is the toggle option that we have seen. This is the main toggle option to do the topology correction for any geometry, whether it might be a 1D geometry or 2D CAD. Like 2D CAD means plastic components or sheet metal components. 3D means that the casting components comes. Any kind of geometry, you can work with this geometry panel only. And I hope you like what I have discussed is very useful for you guys. And the things hopefully I have covered the things what we have mentioned in the module 1, from the downloading the tool to the repairing CAD. And if you are having any doubts respective for this module 1, you can discuss with me. Thank you.
Thank you, Tara. Thank you for the session.
Yeah, thank you.
We'll take the questions.
If you are having any doubts or if you need any clarifications about this module 1, you can ask us. We are helping you in sorting your questions, answering your questions. This module 1 is only on the basics of the what is the hypermesh geometry contains, how to work on the basic operations and theory behind the finite element analysis.
Sir, I have shared you a link of YouTube Live. You can open it so that you can get the questions.
Okay, Vinayak, we'll go one by one, the queries.
Sure, sure.
Yeah, okay. Here someone, Arjun is asking how many elements there are in the 2D. In the 2D, we are the triangular elements or the quad elements. The quad elements means might be a square element or maybe a rectangular elements. These are only the two elements which we are using for the 2D. What is an OptiStruct? Actually, OptiStruct is a solver where we are going like just now what we have discussed, like building the model, applying the material things and all. We need one platform to solve everything. HyperMesh is a not a solver. It is a pre-processing software where we are going to build everything in HyperMesh. Then we need one platform that to see, for example, you are working on crash, you need LSDNA software. That is the platform. Like this, OptiStruct is on one solver where we are going to solve our model. How to change the mesh quality from dense to fine means either you go by remeshing or by changing the global element size, you can change it. The software name is HyperMesh. How to download the software? You can enroll yourself in the Decibels. There are the steps available to download the software. If anything you guys want to ask about the today's session, you can ask me. I'll I'll solve the questions. Yeah, STL file you can import it. Yeah, for the STL file you can import it. As I said, there is a software compatibility for the licensed version. You can import the many CAD design softwares, but for the some other say for example for the student version, it is restricted for few design softwares. You can import STL file. Like it is not restricted for the nodes and nodes. It is not restricted. You can create n number of nodes. The only thing is your system should be having that capacity to take that nodes. The meshing means you cannot do like certainly if it is a if your laptop or desktop it doesn't have any graphics cards, if the RAM memory or the RAM speed is very less means obviously it will not take. If the system capacity is very good, you can create any n number of nodes. It all depends on your system memory and the graphics card. And the hardware capacity, it matters to keep the elements. Thanks for joining the session. And tomorrow we are having the session on 2D elements. We are going to discuss, we will give one component. If you are having HyperMesh software, this is good to have. Tomorrow we'll extract a mid surface and we'll start doing the elements, how to create the elements, what are the things to be taken care while doing the meshing, and what are the quality parameters for the 2D meshing. We'll discuss in the tomorrow, that in the module 2, we will discuss it.
Thank you, guys. Thank you for attending today's session, and thank you, Tara, for the hosting the session. We'll meet tomorrow. Same time at
Thank you all.
5:30.
Thanks for joining the call. Thank you.
Thank you, everyone. Have a good day.